Hello everyone. We are in week number third of artificial intelligence unit, and the focus of week third lab is to understand learning techniques. So when I say learning techniques, it means that we are going to focus on machine learning techniques. That is machine learning techniques. So before starting anything uh, in machine learning techniques, you should know what are the different machine learning techniques are there which you can use for solving your real world problem. So this slide, this video presentation focuses on understanding what is machine learning, and the focus will be on one of the machine learning techniques in this lab, that is in lab number third. So here you can see the title is learning techniques. So basically, if you are going to define machine learning technique or learning technique, basically what you're going to do, you have your machine, that is your computer, and using this computer, what you want to do, you want this machine to learn from the data. You have data. This data may be in any form, in the form of images, in the form of videos, in the form of text data, in the form of numeric data. So what you are going to do, you are going to use this data and you will provide this data as an input to your system, and you want to get the output from this data. So in order to process, so you are going to apply some processing here. So if you see the general architecture of a computer system, it is simply input, you are performing processing, and you are getting some output. So this is general processing of system. So here, if you are going to relate this block diagram with this example, then this is your input. Processing will be done by this machine, and you want to get some output over here. So when we say processing, here the term processing defines the learning techniques. So this is what we are going to learn in this lab session. So introduction to machine learning. So what is machine learning? So first of all, you should know what is machine learning. The definition is pretty simple, and if you will read different books, a textbook, reference book, or research articles such as conference or journal article, you will see different definitions, but I have given this definition: the application of science. So what is machine learning? How you will define machine learning? Machine learning is an application of science, of algorithms which makes sense from the data. So as I said in my previous example, you have been provided data, you are going to implement your algorithm, and your algorithm will make sense from this data. So this is the simple definition of machine learning. So it transforms data into knowledge. So you will get what is the knowledge, what is the information, actual information present in your data. So machine learning plays these days machine learning play a very important role in the field of artificial intelligence. If you remember in my last class, what I said, you need to define what is the difference between machine learning and artificial intelligence. So artificial intelligence is basically a broad area. So if you are considering this is artificial intelligence, so under artificial intelligence, there are subfields, and machine learning is a subfield of artificial intelligence. Computer vision, some students are studying computer vision. Computer vision is a subfield of artificial intelligence. Natural language processing is a subfield of artificial intelligence. So artificial intelligence is an umbrella term. Under artificial intelligence, you will see subfields, and machine learning is one of the subfield of artificial intelligence. So what we want to do, we want to give training to the machine for self-learning, and we are intended to create self-learning. And why we are creating self-learning algorithm, or why we are interested to learn machine learning techniques, because we have been provided data and we would like to make sense from the data. That is, we would like to get what is the knowledge present in the data. So it is data driven approach, which makes predictions or classifications. Supports data driven approach, I already explained. So here you have to have data if you are going to apply machine learning techniques. So that is the reason, if you remember, when I said in this semester you are going to work on assessment, and your assessment will consist of a project. So you are going to work on a project which you will select, project or case study. So when you are selecting your project problem and preparing the proposal, so that is the reason I provided a template for the proposal. And if you will see the last section of the proposal template, there is a section given for data set. So you have to have a data set if you are going to apply machine learning techniques. So it is a data driven approach. Key application areas of machine learning. So robust email spam filtering. It has application in text and voice recognition software. Reliable web search engines you can create. Chess playing game, you can develop games using machine learning techniques. Self-driven car, autonomous car. Application in healthcare sector, you can read this literature if you would like to understand the application areas of machine learning techniques, deep learning, supervised learning technique, unsupervised learning techniques in the field of healthcare. Then you should read this article. And researchers at DeepMind is a group, and researchers in DeepMind, what they are doing, they are implementing deep learning techniques. These days deep learning technique is very popular to predict 3D protein structure, which is one of the challenging tasks in the field of healthcare sectors. So these are some application areas which I have highlighted. When you will start working and implementing machine learning algorithms, you will come across other applications where you will see the role of machine learning techniques. So all in all, machine learnings are techniques are broadly classified, or you can say divided in three main group. So you can see three main types of machine learning techniques you will study in this unit. Supervised learning techniques. So the first technique, which is called as supervised learning technique. Second technique called as unsupervised learning technique. And third machine learning technique is called as reinforcement learning techniques. So what are the fundamental difference? How you will get to know that this learning algorithm or this learning method is supervised, or it is unsupervised, or it is reinforcement. So in order to understand the difference, I have given the next slide. So what is supervised? I will start with supervised. So the data which you will use for your algorithm, if the data is labeled data. So what is the meaning of labeled data? I will explain, but for the time being, you just keep in mind, if the data is labeled data, then you will apply supervised learning technique. Direct feedback, you can get direct feedback from the data, and you can predict the outcome or future, what will happen in the future if you are implementing supervised machine learning technique. Here in case of unsupervised, so you can see labeled data. Here no label on the data, so there will not be any label on the data. No feedback, you will not get any feedback. And find information or knowledge from the hidden structure in the data, whereas since the label is given, you can get the feedback. So here finding knowledge from the data is much easier. but it doesn't mean that it is easy to implement supervised or unsupervised learning technique. Both have almost the same difficulty level. On the other hand, in case of reinforcement learning, it is used in decision process, a reward based system. So like there is a player playing a game, there is opponent player playing a game, this is the game they are playing, let me call it G, and both the players are playing. So if the decision made by player 1 is correct, then this player will get some reward. On the other hand, if this player is getting reward, it means that this player is penalized. If this player is making a wrong decision, then a penalty will be applied. So reward based approach and penalty based approach. So reward if decision is correct, and who will make the decision? Your system will make the decision, and the player will be your system. So if your system is making a correct decision, give reward to the system. If the system is making a wrong decision, apply penalty. And learn from series of actions. So taking a series of actions and based on reward and penalty system, and mostly used for decision process. So this is about the difference between supervised and unsupervised learning technique. So now let me explain you what is the meaning of labeled, unlabeled data. So labeled data, you can see here, by looking the picture, you can understand this is dog. By looking the picture, you can understand this is dog. So where is the label? This is the data. Sorry. This is your data. This is your data. This is your data. And this is the label for the data. This is your data. This is the label for the data. This is your data. This is the label for the data. This is your data. This is the label for the data. This is another example. This is the data and this is the label for the data. Data label, data label. Here you will just get the data without label. There is no label. So here the data is unstructured. No label, hidden. So you need to, your algorithm should be capable enough to understand this is dog. On the other hand, if you are applying supervised learning technique, then the label is given. So you are clear about, your algorithm is clear about what label is given, and you can get direct feedback and you can predict the outcome. This will be happen if your system will process this image. So this is about a labeled and unlabeled data. If there will be any confusion, you can discuss with me. Now, in this session, that is in lab third, my focus will be mainly on supervised learning technique. So I will only cover supervised learning technique, and about discussion about unsupervised and reinforcement learning technique will be in the upcoming labs. So the main goal is to learn a model. So we are going to create a model, and this model will run in this machine. Data will be provided as an input. What your model will do, your model will process the data and predict something based on the labeled. So you are going to use labeled training data. To make prediction, you will make prediction if the image is there and this image is for the dog. You are not going to tell the this machine the image is for the dog. Your model will process this data and model will tell you the image is nothing but it is dog. If the image is for cat, your model will process this data and your model will tell the image is for cat. So make the prediction for the future data. So in future, if you will process any new data, so this is the data in your data set. In any new data will come in a real-time system, then what will happen? Your model should be capable enough to process this data and tell you the new image is for the dog or it is cat. So make prediction. So the term supervised, why it is supervised, refers the set of training examples where desired output signals are already known. So you are clear about the image is for the dog, the image is for the cat. So this is supervised. That is why we call it supervised. So you can see here, you are processing the training data. The data is already labeled. This is what we already discussed. You are implementing your machine learning algorithm. So what will happen initially when you are creating your machine learning model at the time of development of machine learning model, you will give training data to your model. Then in order to validate your model, you will use test data, and to test your model for the validation purpose. Then you will process any new data which is not in the system or in your data set. Then your machine learning model will work as a predictive model, and it will give you the correct prediction. If it is giving correct prediction, it means that your model is working correctly. So you need to evaluate the accuracy of prediction of your model. Accuracy of prediction of your model. So this is what you are going to do when you are going to implement your machine learning, supervised machine learning model. Some examples like email spam filtering is one of the best example. So you are going to classify, you are going to create a two category. One is spam email, another one is non-spam email. So email are coming to your inbox. This is your inbox, and you are going to filter the email based on it is spam email or it is non-spam email. So you are going to create binary class classification. So you will classify, let me assume this cross represents spam email and this star represents non-spam email. So you are going to create classification of email data. So to predict whether new email belongs to this group, that is spam email or non-spam email, if new email will come. So supervised learning task will with discrete class label called as classification task. So basically you are creating a classification. And since you are just creating two classes, so it will be called as binary class classification. So this will be binary class classification. So you can see here what is classification. So I already explained this, what is binary class classification. So you are setting some rules for your model, and your model will process the new email. And if the new email will be a spam email, it will fall in the category of spam, or it will go in non-spam email category. Like this is all I already explained this. So plus, for example, plus represents non-spam, minus sign represents spam email. So you can see here 30 training data examples have been used, and this 30 training data is divided into two groups, 15 and 15. So 15 is the training for the training purpose, and remaining 15 for testing purpose, to test model performance. And it is represented as minus and plus, which you can see here. So this is simply two-dimensional representation of your data. This is x-axis, this is y-axis. Here it is represented by x1 represents x-axis, x2 represents y-axis. So you are basically creating a boundary. So this is called as, this line is boundary, and it separates your minus, or you can say spam email, non-spam email. So as far as supervised learning techniques are concerned, let me rub this. As far as supervised learning techniques are concerned, there are two most popular techniques comes under supervised. The first one is classification, which we just discussed, and the second technique called as regression technique. So we already discussed what is classification, which you have just seen. Minus category, plus category, you can make more classes. If there are more classes, you can create 0, 1, 2, 3. You can use coding for representing the classes, which you will see when you will start implementing your program. So the second category technique which fall under supervised learning technique, known as a regression technique, and we use regression for prediction. So regression technique, we are given a number of predictor, explanatory variable, and a continuous response of the variable. So you have something like x is the given data and y is its response, and your aim is to find out the response, to predict. If you have been given x1, x2, sorry, x3, x4, xn, these are the input data predictor, and you have response for each. For example, y1, y2, y3, y4, and yn. So for x1, the response, predicted response is y3, or it is y1, or it is y2, or it is y4, or it is yn. This is what you want to predict. Similarly, for x2, which response is the correct response? This is what you want to predict. So you have been given input data, that is data. You are going to develop a model, and this model will process the data and predict the response. So this is what you are going to do in regression technique. So it sets the relationship between input, that is a predictor, and response, and the answer will be predicted response. And I think you have studied this kind of thing in your schooling, especially in maths. So y is equal to a plus bx. So this kind of thing you already studied. So here in this example, if as a tutor, what I want to do, I would like to understand, I would like to predict machine intelligence score of my student. I'm teaching in a class, and this class is, what this teacher is teaching, this teacher is teaching a unit called as machine intelligence unit. And what this teacher want to do, this teacher want to set up a relationship between time spent on the study. If there is a student in this class, if a student is spending more time for study, so what is their score? They are passing the unit, they are getting merit, they are getting outstanding grade, they are getting very good grade, they are getting good grade, or they are getting fail. So this is the problem. And how this teacher want to predict this result? Based on the time spent in the study. So this is, what is this? This is, if let me go back, so this is number of predictor variable. So predictor variable is time spent in the study, and outcome will be student is passed or student is failed, that is final score in the assignment. This is the problem. So what this teacher will do, teacher will apply some machine learning technique. Since the problem is prediction problem, so regression technique will be applied in this case. And what this teacher will do, if he is applying regression technique, he will create a training data set to learn the model. So he will create a model, and suppose there are 100 students in the class. So what he will do, he will split this data set. This is the data set. So this data set will be divided, let's say 70%, 70 student in the training data set, and rest 30 to validate the model will be test data set. Try to understand this term, because you are going to do this in your coding also. So you have been given a data set, this teacher has been given, or this machine learning model developer have been given this data set where the data points are 100. So what he does, he has divided this data set in two parts. First part called as training data set, and the second part called as test data set. And then the model will be used to predict the relationship between study time and assignment score. That is this. So assignment score, if it is y, then, and study time is represented by x, then using this score, that is predictor variable and response variable. So using this standard regression formula, you can predict the performance of a student using regression technique. So your model will be trained using this equation, this formula to predict the performance of student in machine intelligence unit. So this is what regression technique will do. So basic terminologies and notation. So you should know how to understand a data set. So to make you understand the basic terminologies of a data set and notation of a data set, because you should know before implementing the model. Because if you are unclear about your data set, it will be hard for you to identify. You should go with supervised learning technique, or you should pick unsupervised learning technique, or you should select the reinforcement technique. So here I'm going to take one data set for explaining this to explain this concept. So the data set which I'm going to use is Irish dataset. Irish dataset is a flower dataset. It consists of 150 flower information. So Irish dataset contains measurement of 150 Irish flowers. It is a flower based dataset. So you can see the species of data you will see in this dataset is this. Each flower sample represent one row. So if it is represented in the table like this, so how many rows are there? Row number 1, row number 2, row number 3, row number 4. So it means that if there are 4 rows, so how many flowers informations are stored in this table? 4 flowers. So one row in our data set, that is this data set, that is Irish data set, each flower sample represents one data set. So in this data set, in this table, how many rows are there? In this table, we have R1 to R150. So 150, it means that one row, one flower. 150 row, 150th flower. So some measurements are given in centimeter. So this table consists of some measurement, some numeric data, and the data measurement is in centimeter, are stored in column. So this column. So this is the example. This is, you can see. So in this, you have row number 1 to row number 150. So 150 flowers informations are stored. 5.1, 3.5, 1.4, 0.2 is for this flower, Setosa flower. So here we are going to apply supervised learning technique, and one of the necessary criteria for applying, for selecting supervised learning technique is the data should consist of label. So you can see here label column is given at the end of this table. So here you can see length is given, width is given, length is petal length is given, petal width is given. So this is called as feature. So how many features are there? 4 features are there. You can see here features, attributes, measurement, dimension. So this is features. So how many features are there? For flower 1, 4 features are there, where sepal length is 5.1, sepal width is 3.5, petal length is 1.4, petal width is 0.2. Similarly, in case of Setosa, in flower 2, 0.2 petal length, 1.4 petal length, 3.0 sepal width, and 5.9 sepal length. So we are not worried about what type of it is given in decimal, it is increasing, it is decreasing, or any other. We are mainly concerned about the label if we are going to apply supervised learning technique. And since the data set consists of label, so without any doubt we can go with supervised learning technique. So this is the idea. So columns, in when you are reading a data set, then columns represents attributes. Keep this in mind. How many attributes? How many feature vector? We call it feature vector. Feature vector 1. This is feature vector 2. This is feature vector 3. This is feature vector 4. So how many feature vectors are there? We have 4 feature vectors. This is attributes, feature vectors, features. So this is some terminologies about this data set. So to understand the implementation in matrix, so why I said matrix and vectors notation, you should know how you will represent your data set in the form of matrix and vectors. Because if you are unable to understand this process, it will be hard for you to implement Python code for processing your data set. So we are going to understand how you are going to use matrix and vector to represent your data set. I suggest you to read linear algebra in order to understand matrix operation, like how to add to matrix, how to get transpose of a matrix, how to get transpose of a vector, how to do matrix multiplication. So some basic operations are related to matrix and vectors. So I highly suggest you to go through matrix and vectors in linear algebra. So suppose uh, this data I'm using X to represent this whole. That is, this whole means starting from row 1 to row 50. Row number 1 to row number 150. It is represented by this X, notation X. Okay, so X is the feature matrix. And if X is your feature matrix, then we are using a real number to represent the feature matrix. How many features are there? 4. So 150, generally we use m cross n, if you are clear about this. So 150 rows, 4 columns. Let me go back and show this to you. How many rows? 150 rows. And how many columns? 3 columns. Sorry, 4 columns. Column number equal to 4 and rows are 150. So this is the thing we discussed now. So X represents your feature matrix, that is this whole is represented by X. 150 samples, 150 rows. How many feature vector? 4 feature vector, 4 attributes can be rewritten as 150 multiplied by 4. And what is this? X is your matrix, that is this matrix is represented by X. It belongs to a real number, set of real number, because all these are real numbers. And what is the size of this real number? 150 multiplied by 4, that is 150 rows, 4 column. And you can see it like this. So this x11 means I'm talking about 5.1. x21, it represents 3.5. x31, it represents 1.4. x41 represents 0.2. x12 means 4.9, and similarly for rest all the data points given in this matrix X. So this is just a simple representation of your data set, and you should know this because you are going to write your program, and in your program you are going to create matrix, you are going to perform some operation on the matrix, you are going to create vectors, you are going to perform operations on the vector. For example, you do not want to consider all the 4 features, all the 4 attributes. So for performing some operation, you just need first 2. So how you will ignore the remaining? You just want to take these 2. Or in another case, you are interested to take only this vector to perform certain action. So how you will select, how you will ignore this one, and the last feature vector. So you should know some basic operation of matrix and vector. Now, if we will discuss 2 main technique under supervised. So far we discussed the definition of machine learning technique and 2 techniques under supervised learning technique. First one is classification, and the second technique we discussed was regression technique. And then we talked about data set, and as far as data set is concerned, we discussed iris data set and some notations about the data set. Now if you are going to implement or develop your model, machine learning model, forget about supervised, unsupervised or reinforcements. reinforcement. We follow a standard approach when we develop our machine learning model. So this slide will give you an overview of how to develop your machine learning model without worrying about you are implementing for supervised, you are implementing for unsupervised, or you are going to implement a reinforcement learning. So this model will give you a general overview of developing or building your machine learning model. After completing this slide, you will be in a position to understand uh, the key steps which you should follow in order to develop your machine learning model. So I will begin with this model. So you can see here, this diagram is basically divided in 4 parts. Let me call it part 1, part 2, part 3, and part 4. And you can see the name for each part is given. So the first part called as pre-processing, second part called as learning, third part called as evaluation, and the last part called as prediction, and you will get your output. So I will give the detailed explanation about each part one by one. So here I will begin with the first part, that is pre-processing. Generally we call it as pre-processing of data. My writing is not so good. Data or pre-processing of data set. So we will discuss this pre-processing of data set in the first block. As we discussed, so far we discussed the supervised learning technique. So I consider only label data, data set, raw data which has label. If you are going to implement unsupervised learning technique, then you can ignore this part. So what will be given to you? You will be provided the data set, that is this. This is your data set, raw data. Or you can call it as your data set, which you can get. Your client will provide, or for AI project, or for data processing project, or for computer vision project, or for your master project, you will be asked to explain or provide the information about the data set. Then here is your data set. So you need to find out data set. If you are working for any industry, then your client will provide the data, or you will be asked to prepare the data set. All right, so this is about the data set. So what you will do with the data set? You will apply some initial step before implementing your actual model. So your actual model is here. So before providing input to your actual model, you need to check your data set, which is very, very important. And then training and splitting the data set as training and test data. So when you will get raw data will be, it may be structured, or it is not structured. It will not be non-structured format. Non-structured format. There may be some null values. There may be some other problem associated with the data set. So what you are going to do, you are going to check all these things before processing, before using your data set as an input for your actual model development. So this step called as pre-processing. So where in pre-processing you will check the nature of your data set. So what is the meaning of pre-processing? Pre-processing means checking the nature of the data set. If there is any null value present, remove the null value. If the data is not organized, you need to organize or structure your data set. So we call it raw data. That is the reason raw data term is given. So after pre-processing, what you will get? You will get a structured, organized data set. So structured and organized data set. Now, in order to develop your model, what you will do, you will split your data set in two parts. We can call it as training. We can call it training data set and test data set. So what does this training and test data set means? Training data set can be referred as the data you will use to train your model. So this is your model, machine learning model, in order to give training to your model at the time of development, because it is not possible for anyone to develop the correct model just in one go. So what you will do, you will give training. Your model will not initially, maybe your model is not behaving appropriately. So you will tweak, you will make changes in the parameters of the model, and you will train your model. So for the training of your model, you are going to some part of your data set, and this data set will be called as training data set. Now after training, now training is completed, training is done. So after training, in order to validate your model is performing correctly, how you will get to know that? You will use then test data. Then you will process your test data on this model. And this model, when I say this M model, it is already trained. After training, you believe that your model is showing a good behavior, it is showing good result, it is predicting or classifying your data correctly. Then in order to validate your model, you will use the test data, and you will use this test data as an input to your model, and you will see the performance, how this model is behaving. Is this model working correctly? If it is working correctly, you will check the accuracy. There are several benchmark matrices you can use to check the quality, robustness of your model. So training data for training the model, test data for validating the model. So this is about the data. Now learning. Now you are ready with your training data set, you are ready with your test data set after completing pre-processing step. As I already explained, training data set will be used to train your model. The learning algorithm, you will implement your learning algorithm. You will see how your model is working. You are giving training, you are making changes in the model. So what we'll do, this is called as model selection. You will validate your model, cross validation. You will use performance matrices like accuracy, precision, recall. There are several matrices, performance matrices you can use to understand how your model is behaving. If the model is not working or showing good result, what you will do, you will make changes in the parameter. It is called as parameter hyperparameter optimization. We will discuss all these things one by one, but since this is the first lab where you are going to develop your model, so you should know the steps. So this process called as learning. So basically you are giving training, you are making your model to learn. Now after completing your model, what you will do, you will get your final model, and then you will use your test data here to the final model. And if the model is working correctly, then what you will do, you will say that your model is good to predict or to classify the outcome. So after completing this training process, that is learning, testing process, that is evaluation, what you will do, you will process any new data. And if your model is capable to give you correct label or prediction, it means that your model is showing good behavior, it is showing high accuracy, or error is less. So these are the steps you need to follow when you are going to develop a machine learning model, without worrying about it is supervised, it is unsupervised, or you are going to develop a reinforcement learning model. So I think this is the last slide. Thank you very much.